In this video, I'm going to find the tangent line at theta is equal to pi over 4 for the cycloid defined by x is equal to r times theta minus sine of theta and y is equal to r times 1 minus cosine of theta. As you already know, the formula for slope dy over dx is equal to dy over dt, but in our case t is theta, so dy over d theta divided by dx over d theta. Theta is the parameter that we are talking about, right? Since this is a parametric equation. So let's go ahead and find the dy over d theta, so which would be this, right? So derivative of this is going to be nothing but sine of theta times r divided by dx over d theta. So that's going to be nothing but r minus r times cosine of theta. Now if I simplify it, the r's are going to cancel out. That's going to give me sine of theta over 1 minus cosine of theta. That is my slope, by the way. Now we need to find this slope at point theta is equal to pi over 4. So my slope m is going to be equal to sine of theta over 1 minus cosine of theta evaluated at theta is equal to pi over 4. Now you know sine of theta is equal to square root of 2 over 2, and same for cosine of theta, right? So my slope in essence becomes square root of 2 over 2 divided by 1 minus square root of 2 over 2, and I can simplify it a little bit. Square root of 2 over 2 divided by 2 minus square root of 2, all of it divided by 2, and that's going to give me my final slope, square root of 2 divided by 2 minus square root of 2. And if I really wanted to get rid of the radical in the denominator, I could do so by multiplying both numerator and the denominator by the conjugate of the denominator. That means conjugate of 2 minus square root of 2. So let's just do it. Square root of 2 times 2 plus square root of 2, then 2 minus square root of 2 times 2 plus square root of 2. So that is going to give you in the denominator 4 minus 2 using the difference of squares formula, right? A square minus b square is equal to a plus b times a minus b. And on the top you're going to get 2 plus 2 square root of 2. That's going to give you 2 times 1 plus square root of 2 on the top. And in the bottom, 4 minus 2 is 2. So finally, my slope becomes 1 plus square root of 2. Now that we found the slope, m is equal to 1 plus square root of 2, we could use this slope to find the equation of the tangent line, which is very easy. You could use this formula for straight line y minus y naught is equal to m times x minus x naught. Now y naught and x naught are the values of x and y, right, at theta is equal to pi over 4. You could evaluate that and find the following. So my x naught is going to be equal to r times pi over 4 minus sine of pi over 4. But sine of pi over 4 is square root of 2 over 2. And similarly, you could find y naught, okay, is going to be r times 1 minus cosine of pi over 4, which is square root of 2 over 2. Now you could take these values, x naught, y naught, and m, and plug it into this equation to find the equation of the tangent line. Now I'm going to talk about horizontal and vertical slopes. So my formula for slope is m is equal to sine of theta divided by 1 minus cosine of theta. Now remember, your slope is going to be horizontal when the value of m is equal to 0. m is equal to 0, which tells us that we are going to have horizontal slope when sine of theta is equal to 0. That means this numerator is 0. However, we have to be very careful is that when sine of theta is equal to 0, we have to make sure that 1 minus cosine of theta is not equal to 0. That is to say that cosine of theta is not equal to 1. And under these conditions, your slope is going to be horizontal. Now, you know that sine of theta is equal to 0 when theta is equal to either 0 or pi, okay? And then you could have 2 pi, 4 pi, 3 pi, 2 pi, 3 pi, 4 pi, but let's just stick to 0 and pi, and let's kind of put a theta between 0 and 2 pi, okay? Now, if sine of 0 is 0, then in that case, cosine of 0 is 1. So 1 minus 1 is going to be 0. So theta is equal to 0 is not an option. However, theta is equal to pi is still going to be 0. Sine of pi is 0. However, cosine of pi is negative 1. So it's going to be 1 minus negative 1, which is just 2. So in that case, denominator is not going to be 0. So our horizontal slope is going to be at theta is equal to pi. So theta is equal to pi, not theta is equal to 0. Now, similarly, we can find the vertical slope. Vertical slope is going to be when the denominator is 0. So that means 1 minus cosine of theta is equal to 0. But we need to make sure that at that time, sine of theta, for that theta value, sine of theta is not equal to 0. Why? Because we don't want to be in a situation where we are doing 0 divided by 0. So that's why we have this additional condition to make sure that the numerator is not 0, but the denominator is 0. So cosine of theta is equal to 1. Now, this one is a little bit tricky. Cosine of theta is going to be 1 when theta is equal to 0, which is also 2 and pi, okay? In our case, we'll just stick to 0, all right? So now, if you have theta is equal to 0, in the slope formula that we got, sine of 0 is going to be 0, and 1 minus cosine of 0 is 1, which is also 0. So we are running into a situation 0 over 0. Now, what we could do, we could use the L'Hopital's rule. So limit theta approaches 0, sine of theta over 1 minus cosine of theta. So this becomes 0 over 0, which is the same as limit theta approaches 0. Derivative of sine of theta is going to be cosine of theta divided by sine of theta. Okay. Now, as theta approaches 0, cosine of theta approaches 1, but sine of theta approaches 0. So we have a situation where the slope is going to be infinity. Okay. So from this, we could conclude that the vertical slopes are going to be at theta is equal to 0. And you could extend it to the other angles, 2 pi, 4 pi, 6 pi, etc. Now, to summarize, we talked about tangent. That means finding the slope, dy over dx, we found the slope. Then we found the equation of the tangent line. Then we found the conditions under which the slope is going to be horizontal. And we found the condition under which the slope is going to be vertical. I hope that this discussion was helpful. Thank you very much.